So I use it as kind of inspiration of just code a little bit every day, and you'll kind of see right now what you get if you just code a little bit every day and make some tools. So give it up for Hassan.
Thank you, guys. Okay, how many of you, a couple of questions just, for me to know you a little bit better. How many of you have been here for the presentation last year? Okay, good. And how many of you are actually using Python to do programming? Okay, cool. Okay, so last year when I introduced pyRevit was a much smaller tool than what it is right now. During this time, I spent a lot of time improving the back end really of the pyRevit that helps you load the tools and gives you like more features that you can use in pyRevit without necessarily interacting with Revit's own API. For the people that haven't been here last year, a little bit about programming basics. There is this thing called API, which is the application programming interface. This is whenever you get an application that is like professionally developed and has a lot of features and stuff like that, the developers choose to provide an interface for the users to be able to interact with the software on a programming level, basically. You have the user interface for the normal users that want to like do stuff and use the tools and whatever, but then behind the scenes there is another interface which is just the programming that helps programming languages and the programmers to connect to the features in the software and use those to do all sorts of stuff. It doesn't mean that necessarily all those features of the software are exposed in the API. The programmers choose not to expose some features, especially with like complex programs like Revit, because Revit has this database of objects behind the scenes that is very fragile and it needs to maintain it really well. So it exposes certain features and heavily controls those because that is your interaction with that database. So it puts abstraction layer on top of abstraction layer to basically control its own database. So you can't expect the API to do everything. You might have a tool in the software that there's no API methods for it to use that feature. So those are kind of like limitation and also features of the API. And then you come to this point that, okay, so I have this API, I understand it, I have the documentation for it, I can see like what stuff it does. How can I interact with it? That is through the programming language. It's generally, like it used to be like this, that before the programming language that the software was written in would be the language that you had to use its API. Because of the way these languages call each other functions and stuff like that. With .NET platform in Windows, they created something that's called Common Language Runtime, and it is basically an abstraction layer on top of the hardware for different languages. So the code that you generate with Visual Basic and the code that you generate with Visual C# or C++ CLR. They all have the same bytecode in the background. This is the feature that developers of IronPython use to connect the Python language to the .NET backend of .NET programs, basically. For those of you that know IronPython, that's why you import CLR whenever you want to do something. That CLR is the common language runtime that runs behind the scenes, and you can load DLLs and connect to Revit features and all sorts of stuff. IronPython is not necessarily for Revit. It can connect to any program that runs .NET. But for this, you can also install IronPython as an independent individual environment. You don't really necessarily have to use it within Revit. So you can use it for all sorts of stuff. We call the programs that you write and compile, they're called basically programs. I'm trying to explain the difference between compiled and interpreted languages. Compiled languages are the ones that you write the program. Both of them, you write a program in a text format within the syntax and the rules of that programming language. But then you get it compiled in the compiled languages, and it turns it into bytecode or the, let's say, assembly code for the machine, and it runs on the machine. This is the most efficient and fastest way of doing stuff, but it limits you to the platform that you're using. That's why you can't run a program that's compiled for Windows on a Mac system, because the hardware is different, the behind the scenes are different, the OS calls are different, all sorts of stuff, and they are basically baked into that program. The beauty of interpreted languages is that on every platform you have an interpreter, like Python for macOS, Python for Linux, Python for FreeBSD, Python for Windows. And this is the program that basically interprets your text document, which is your script, and runs it on the machine. The beauty of this is that you can run the same script on all sorts of platforms, all sorts of machines, theoretically with no problems. Some operating systems have external features. For example, on Windows, if you want to use Windows Registry, none of the operating systems have that feature. So that would limit you, but this way you can write a smarter code that check, okay, if I'm on Windows, do this. If not, do the other stuff. So technically you can do this, but this means that if you write a script, you can run it anywhere. That's the beauty of running scripts, basically interpreted languages. The cons of this is that it is much slower than the other languages, because there's this abstraction layer on top of abstraction layer on top of abstraction layer. So your interpreter has to understand your code, and then that's generally the load time. That's why like these tools, the IronPython tools, are a little bit slower than the actual Revit tools, because it takes a little bit of time for IronPython to load the script, understand what you're doing, create the environment for it, and actually connect it to Revit and run it. We are having faster and faster computers every day, so that is basically less noticeable now. A little bit about Python. Python is a programming language, just like C++, for example. Programming languages have standards. They are controlled by a committee that decides which features this program should have and how the syntax should work and all sorts of stuff. And they create a document that describes, it's like the specification for your building. It describes what this thing is. But then programmers go and take this specification and develop the compiler or the interpreter for that program. Like C++, the newest standard is C++ 17. Visual Studio, which is for Microsoft, takes these standards, develop a compiler for C++. GCC, on the other hand, on Linux does that. Clang on other systems does another thing. So each one of them is a different compiler for the same language. And based on the version of compiler they're using, they adopt certain features here and there. For IronPython, that's the main difference between Python and IronPython. They're both Python, but they're two different implementations of Python. Python is the language. The CPython that we call it, that you download from Python website, that's the CPython. That's the implementation of Python in C language. That's the fastest and the most efficient one. And it has the most features, and it has the most complete, because the Python language is really governed by the same committee that writes that CPython interpreter. IronPython is different. It's written in C# because they wanted to connect to .NET applications. That's why the version on this one is 2.7, and it conforms to the 2.7 Python standard. It's a little bit behind in some features. You see some errors. For example, just before this 2.77 version, they had a problem with Unicode strings, which they resolved in the new one. So there are some differences between the two. That's why you can't always use the modules that you get for the actual Python in IronPython, because the internals are a little bit different. That is not a limitation of the language, that's a limitation of the implementation. The people who develop IronPython who should be more careful about properly implementing those features, so you can run the same code that you run on a normal Python in IronPython and get the same system. But at the end of the day, if you use Revit features in your system, in your program, in your script, you're basically limiting yourself to IronPython. Why? Because it needs to have a binding to the .NET behind the scene and connect to Revit. Technically, if you want to use IronPython right now, the best system that's available is Revit Python Shell. It's an application that a guy from, I forgot his university, I think it's MIT, developed that looks like this. There's a top part, that's your command prompt. The bottom part is the pad that you write your scripts in. You can actually do one-line scripts in the top part too, and then it runs your commands. There is literally, you can use all sorts of features within Revit inside this. But the problem with this is that If you want to do something repetitively, every time you have to open the script, run it, get the errors and stuff like that. So it's a little bit slower. What I really wanted to do is to have a system that I have all these scripts written, have a system that when I fire up my Revit, it actually creates all these buttons in the tab, so I can easily launch those, and gives me actually more features like a nicer output and all sorts of like a progress bar, windows and stuff like this. So that's really what pyRevit is. It has two main components. One is the back end of it, what I call the back end of it, which helps you load your scripts into the running instance of Revit. And the other part is the series of tools that are really a showcase for me to show that the power of IronPython for Revit, writing scripts for Revit really, and then actually add some useful tools that I use daily. What I specifically like about interpreted language is IronPython versus the compiled language in C#, because you can write C#, you can write all these tools in C# or Visual Basic for Revit. But every time you make a change, you have to compile it, you have to close your Revit, you have to reopen it, and if you are a BIM manager for a company, you have to talk to your IT, they have to develop all these, basically update their scripts, deploy this new version on everybody's computer, so next time they fire up Revit, they can do it. And it has to be done over the weekends that nobody has the Revit open and all sorts of stuff. With this system, pyRevit reserves an external reference link to the script that is shown as a button in your Revit. So every time you click that button, it runs a new version of that script. It reads the file and runs it. So if you're in a 300 people company, have 300 instances of pyRevit running, and somebody tells you, oh, I got this error with this script, you can go and fix that script, save it, and literally it's updated for everyone, because everybody has a link to that. You don't even need to close your Revit. That's really important for me because my main job is I'm an architect and I have this Revit open all the time, and my models are heavy. I can't afford closing and opening this 10 times a day because I wanted to revise the script a little bit just to run it differently. That's the beauty of it. I have these basic tools, but if I want to do something that's slightly different than that, I can just open the script, make a change, run it, and then revert the change and put it into normal mode. This is the slide that I showed you last year. That was pyRevit, that single script. And then there was a folder that had all these tools in it. That single file, that single file is this now. All of this is pyRevit now. And inside each one of these folders, you also have a script. So it has expanded by a lot. I've made it much much in terms of programming so that developers can understand this core better and they can contribute to it, add new features, make certain features work better and stuff like that. I'll talk about the components of it later after the basically demo of the tools, the new tools really, and I'll basically tell you how it works. So. Yeah, demo. Okay, so I get a lot of questions about installation. Installation is very simple, honestly, in theory. Oh, damn it, I don't have internet. Hold on a sec. Which one is the one that I have to use? Oh, my dude, find my phone.
I think it's AI Guest.
I'll just connect to my phone. Okay, does work. It does work. Did work. Okay. So this is the pyRevit blog. I encourage you to follow this and subscribe to this because that's my main place that I post all the updates and changes about the software. There's 3 buttons: download, installer, read the documents, which is for the people who want to contribute to the core, and view the project on GitHub that you can go and see the source codes and all sorts of stuff. And it's open platform. It uses the GPL3 license. You can use it for anything you want as long as you don't incorporate it in your product and then start selling your product. There are a couple of pages in here that I get to it that describe different features of this. This is the installer. Click on this link and you get this file. This file is a very, very small file. It is about 1.5 megabytes. It does not have the pyRevit in it. It's just a web installer, basically. Whenever you run this and it's installed pyRevit, it clones the pyRevit repository, the head of the repository, which means that this is the newest version. It basically grabs that, puts it on your computer, creates the add-in files to let Revit that this thing is here, and then that's it. That's all it does. It says version 4, means that it works on all version 4s. So when you get a new update for like 4.4, you don't need to download the new installer. Just use this one and it would reclone the newest version for you. That's the nicest thing, is that I realized this is nicest for the IT because they keep the same setup file and they don't need to like change that every time a new version comes in. Install it. Everything technically should be fine, and then pyRevit generally by default gets installed in the your app data. I type it generally like this. This is your app data. That's a smart folder name in Windows. If you copy this and put it in your address bar, it actually goes to that folder. So app data, which is your roaming profile. This is the profile, this is the folder that gets synchronized to your server. So when next time you log into a different computer, it actually brings all your settings and all your tools and all sorts of stuff to that computer also. Which that's why I generally prefer to install pyRevit in that folder, because it means if you use a different computer, you'll still have pyRevit installed on your machine. So pyRevit goes into this folder and gets installed in actually on this computer, this is my virtual machine that I'm running. I've installed it in a different place. But it basically goes here in that folder that says pyRevit version 4, blah, blah, blah. And then there's one config file that is the configuration for that. If it's the first time, it creates this file based on your username and stuff like that and sets up the defaults, and then all this stuff can be changed in the pyRevit settings later. You see there's a 2017 in here. So pyRevit is the same for all your Revit versions. It doesn't install multiple different instances for different Revit versions. It uses the portability of the .NET platform, basically. It works on, the only stuff that breaks is the differences between the APIs of the 2015 versus 2017. They might deprecate some functions, change the platform and stuff like that, and one of the scripts might break. And then I have to go and make that script smart about, like, if you're running on 2015, do this. If you're running in 2017, do this. This is the folder. So I have 2017 on this computer, and I've run it before, and this creates a folder named 2017 based on the Revit version that it belongs to, and it creates all these temporary files inside it. You don't ever need to worry about these stuff, but for troubleshooting, if you have any problems, the first thing you should do is to delete that folder. That's basically the cache for the pyRevit for that version. It creates all this, like it reads all these scripts and creates all these necessary DLLs and puts the hash codes to, so it figures out if it's the same version as before and stuff like that. And everything in pyRevit that is run, for example, under 2017 goes into that folder. pyRevit does not write anything anywhere else. I hate applications that do something in the registry and then the copy files in the temp folder and in all sorts of stuff. So if you delete this folder, like technically if you go into pyRevit and delete this pyRevit folder in your app data, you'll lose pyRevit. You'll uninstall pyRevit. It doesn't exist anymore. The only thing that remains is the add-in file, this descriptor file, which is in your, let's see if I have it here, release, no, that doesn't work. Add-ins, there we go, 2017, it's this one. It's a text file that tells Revit where pyRevit is. So if you uninstall pyRevit that way, which is just deleting it, you'll get an error that, oh, I can't load pyRevit. It's because that single file has to be there. I can't really do anything about that. So anyway, that's pyRevit. I started the, I think I talked about just keep this folder open. And I just realized that I forgot to hit the screen record. I knew I'm gonna mess up somewhere. Okay, should be good. Sorry about the speed of this, because it's a virtual machine and I don't give it much memory. Okay, so this is the window that you generally see by default. It tells you what Revit version you're running, but pyRevit version, Revit version, the build number, the version of the IronPython, and it's running under this. Damn, this screen record is really slow. Let's just not do that. Don't save. Okay, and it just goes away. So by default, if it doesn't give you any errors, I've changed the system so by default, because I got a lot of like questions that can I just close this thing? I don't want to see it every time that I launch Revit and stuff like that. But I kind of like it because it tells you if there's anything wrong going on behind the scene, and if it gives you that okay at the end, everything's fine. So it's good for me, at least for testing and stuff like that. And I've really minimized the amount of information that it gives you. So we added this feature to it that if it doesn't have any errors, it closes after a certain number of seconds. The version that I'm running right now on my machine is the sort of like the development branch. That's why there's some changes to it that I'll tell you about it. Like for example, I've modified this so without opening file, you'll have access to all settings and stuff like that. So that is available now. So if all those configuration and stuff like that, you can go inside settings, and basically there is a field or a section relative to the configuration setting in the INI file. The pyRevit core settings, check update at startup. Do you want to check for the updates at startup or not? This is the one that I get a lot of questions for, the reporting level. There are three reporting levels in pyRevit. One is no reporting, don't show me anything. If you check this, you'll never see that window pop up at Revit launch. Verbose is the one that basically gives you the info messages. Those are the limited messages that pyRevit wants to let you know about the environment that's running on and stuff like that. Minimum information. And debug, you get like a bazillion messages if you activate this, because it reports everything. And normally it runs maybe in 3 seconds. If you active debug, because of the amount of stuff that it prints, it goes like to 30 seconds. So this is only for like if you're developing and you want to actually see what Revit messages. It tells you about every script that's finding behind the scene and how it's interacting with it and what kind of tool it's creating and where is this icon and all sorts of stuff. This debugging system is shared between all these scripts as well, and I'll show you how to use those. There is also a file debug logging option that basically it saves all this information in a log file that has even more information, like has timestamps and stuff like that. And generally, I ask if you have any problems, I ask you to go activate this button, run your Revit, and then send me that file log. And I can see, I have a tool that I can see what's going on inside it, and I can help you resolve the problem. Caching, you don't need to worry about that. This is the one that I added in this new version, that you see all the other versions that are installed on this machine, and you can activate and deactivate pyRevit for the different versions of Revit that you're running from here. Obviously, you can't kill your own, the Revit version 2017 that you're running on. There is a thing for development. If you are using pyRevit for development and stuff like that, there's a parameter. If you define beta in your script, it doesn't load it. So you kind of have to come here and check this box so it loads all the beta tools. This helps you keep the beta tools separate from the actual environment that other people are using it. And I added this nice like iOS buttons to it, so it looks cool. Environment variables, you don't need to worry about it. These are basically just like works like environment variable in the operating system. It basically is a way of sharing information between the pyRevit core and the other scripts. Because what happens is that behind the scene, when you run a script, it creates the engine, runs the thing, and then it closes it and it goes away. That's why I needed a way to basically reserve some information in memory, so the next time a script is running, can look it up and basically use that information. So these are the environment variables, really. You don't need to worry about those. I'll talk about usage logging. This is the feature that I added in 4.2 or 3. This is really for the people that use this pyRevit in large environments. If you want to deploy to a big office and stuff like that, it gives you the feature to log every usage of the tool in a log file or on a web server. So this would technically give you a power to see what tools are being used the most and what tools we really need to work on and create like different flavors of them and stuff like that. It's disabled by default. And then there's custom user extension folder. So pyRevit used to have this default folder that had all these scripts in it. I changed it in a way that it can accept extensions. So every It's technically, you can say every tab is an extension, but behind the scenes it really is not. You can add a panel to a different tab within your extension, so you can do all sorts of stuff, but generally each extension is a folder. Let me actually go and figure out where did I install this thing. I think it's sitting on C. Maybe not here. Okay. Sorry, guys. It's API pyRevit. Oh, Z pyRevit lib. Oh yeah, because it's. Sorry, it's raising off of the other one. Okay, so this is the installation folder, how it looks like in pyRevit, inside pyRevit. There's this extension folder that has all these extensions, and the way pyRevit knows about them is that they have an extension, what is it? Type, basically, postfix. Each one of these extensions, if you go inside it, it defines a tab and it defines a panel, and it has a bunch of like push button, stacks, other stuff in it. So that's what an extension. I'll talk about it in more detail later. But this is the default folder for the extensions. Don't add anything into this, because that generally you're adding that to the pyRevit repository. So, and generally don't add any files inside this, because then the Git tool is going to have trouble resolving the conflicts later. So the nice thing, and it explains it in the setting menu here. The nice thing is that you can create a different folder somewhere on your server that's safe, create your own extension, and then that add folder in here, so pyRevit add startup knows which locations it needs to look for extensions. By default, it does it in its own folder only, but whatever number of folders you add in here, it just looks in those also. So this way you can have your own company tools in an extension, safe somewhere on your server. This loads it off of that, and then you can freely uninstall, delete pyRevit without any of your tools getting affected. This is the really quick overview of how the settings work. I'll tell you about every time I added like a feature or something in the blog. So that's basically the main news source for the changes. So this is how pyRevit looks like. I've added this development tab. I've gotten all these like extra tools in the pyRevit basically here, and moved them into a development extension that you can disable. That's disabled by default. You only enable it if you're doing pyRevit development. It has all these, like, this is the tool that I use for viewing the logs, and this is the tool that I use for viewing the usage logs. There's this unit test that tests the different features and stuff like that. So that's really what pyRevit. Yours is this one, just this pyRevit only, with the extra extensions that you might get from other people or develop yourself. So that I showed you this. The about button is here that gives you the version of, this is where officially where the version of pyRevit you're running, 4.3 this. And this unstable W14 is the branch, the development branch that I'm on. You won't see this here, because if it's on master, it doesn't show that. And then it tells you that it's running on 2.77, which is the latest version of IronPython, and then a bunch of links and stuff like that in here. And update, click this. It'll download the most recent clone, basically the most recent version of the repository off of the GitHub, and update yours, and it reloads your pyRevit technically in place without needing to close Revit. You might, if you are using this in a large environment, your developers might take that tool out, because they don't want individual people to upload. They want everybody to have the same version, so they would get the updates from behind the scene. But you still should have the reload button. This is basically every time you really add a new script, you need to reload. If you went and changed a script without changing its name and stuff like that, you don't need to reload, because it's the same file. It's the same file in the same folder. So this button, if I go in and change the contents of the script, I don't really need to reload pyRevit, because it already has that link to that script. This reload is only for if you added a new tool, or if you like moved tools around and deleted a bunch of stuff and all sorts of things. The extensions in the extension manager, I think it's going to take a while for this thing to open it, because it's so slow. Okay, that's not bad. So it tells you these are the default ones that you get. There's Revit Python wrapper that Guy developed, which is create to For the Python developers, it gives you a wrapper around Revit's internals, makes them a little bit easier to use. pyRevit Plus is also what he has developed, as a bunch of useful tools. These are the standard ones that come with. The pyRevit tools is the one that you're seeing right now, the pyRevit, and then the development tools that I told you about, the pyRevit Dev. So this is disabled by default. It's enabled on this machine. There's one really important feature in this extension manager is the extension package settings down here, which like for example, this is all private and stuff like that. But here, let's say you have a Git repository for your own extensions for your own company, but you wanted to put it on a private repository somewhere on Bitbucket or GitHub or a different Git platform. This is where you can still add it to your extensions and then provide the user and password for that. So next time you update, it actually updates it off of your private repository. That doesn't mean that this extension is shared with everybody else. You just save it somewhere because you have, I don't know, 3 satellite offices and you want to have this extension shared between like 3 sets of developers between those. It might be like a crazy feature that nobody uses right now, but it's there. And the rest of these are just links to the website and the settings button.